Now, everybody go to the slide that says arithmetic series. I'm going to try to put some context to arithmetic and geometric and give you a big picture of it. There's quite a few formulas, and I think they're in your packet, but I just want to show you that you can kind of think out these formulas pretty well. Let's go back to what arithmetic series is. 2, 4, 6, what's after that? 8, 10, 12. So what are we doing each time? Adding 2. So what we're looking at 2, 4, 6, 8, we're looking for a common what? Difference. It's a common difference, yeah. And that common difference we're going to call D, which is A of n plus 1 minus A of n. A weird formula, but it kind of makes sense. It's just the next term minus the previous term. And it's always going to be the same. So make sure that you think about that formula. And then the other one, I think this is kind of cool. To get to this is considered the first term, second term, third term, and so on, right? How many differences does it take to get to the third term? 2. How many differences does it take to get to the second term? 1. So you start with the first term and you add how many differences to get to the third term? 2. How many for the 7th term? 6. How many to the nth term? There you go. And that's all there is to the A of n for arithmetic. You want to know the 5,000th term? No problem. You know the first term. You know it's 5,000 terms. If you know the difference is 2, you can find the 5,000th term. This is so powerful, we just take it for granted. It's huge. Now the sum of those n terms is going to be half of the first term. You take the number of terms divided by 2, and you take the first term and you take the last term. And then you take half. For example, let's say we went 2 plus 4 plus 6 is equal to 12. How many terms is that? 1, 2, 3. The first term is 2. The last term is 6. So if we want to know the sum of the first 3 terms, you're just going to go 3 over 2. First term is 2. Last term is 6. So 12 over 2 is what? 6. So then you've got 8. Yeah, 8 times 3 is 24 over 2. 3 times 8 over 2 is going to be 3 times 4, which is 12. Is that the sum of the first 3 terms? Yeah. And so it works out wonderfully. So the idea here is that if you took the first term plus the last term, multiply by the number of terms over 2, you're going to get the sum. The classic is 1 plus 2 plus 3 plus 4, 5 plus 6 plus 7 plus 8 plus 9 plus 10. What's the sum of the first 10 digits? Should be able to get those real quick. Yeah, because what's 1 and 10? 11. 2 and 9. How many 11s will we have? There's 5 11s. And over 2, the first term was 1, the last term is 10. How about the first 100? Well, just tell me what it's going to be. The first 100 is going to be 50, right? 50 times 1 plus 101, or 50 times 101. How about, by the way, that's 50-50. What's the first sum of the first 1,000 numbers? 500, 500. First 10,000 numbers? 5,000, 5,000. Isn't that cool? And it's all because if you took this one here, 1 plus 10, and then you multiplied by 10 over 2, you can see how that 5 times 11, where that comes from. All right, I'm going to expand this just a teeny tiny bit. You might see it in your formula packet. You might see this: a plus n minus 1 times d. Where did this a plus n minus 1 times d come from? It comes from here, right? This can be substituted in for that. And so now we're going to have a sort of a new formula, but it's not really new. The sum of n is going to be n over 2, 2a's, plus n minus 1 times d. And so these are your arithmetic. They have to have a common difference to work. Oh, let's look at this one. What's the sum of an infinite number of terms in an arithmetic? Infinity. It doesn't converge. It just goes to infinity. 1 plus 1 plus 1 goes to infinity. 1 plus 2 plus 3 plus 4 goes to infinity. Even 1, 0, negative 1, negative 2, that'll go to negative infinity. Not helpful for arithmetic. But, and here's a nice problem I'll have you look at. Now let's look at geometric. 3, 9, 27. 3, 9, 27. Now this one has a common what? Common multiple. You're multiplying by what? 3. So we call this a common ratio or multiple. I like ratio. And so this ratio is equal to the next term divided by the previous term for any of those you have. Please write that one down. I don't think it's in your packet. So think of it this way. To get to 27, how many ratios do I multiply 3 by to get to 27? 2. What if I want to get to 9 here? How many ratios do I multiply times 3? 1. So the formula is a, the first term, times the ratios to the what? N minus 1. Yeah, because what happens here is that if you went to 81, this would be the fourth term. How many of those ratios am I going to have to multiply 3 by to get to 81? 3. So ratio to the 4 minus 1 times what you started with. Notice how related these are. The first one, the arithmetic, we took the first term and we added difference times n minus 1. What's this one? We take the first one times the ratio to the n minus 1. See how they're related? You don't have to memorize those. They just kind of make sense. And then for the sum, this one's very complicated to prove. I'm just going to give it to you. It's going to be the first term times 1 plus r to the n all over 1 minus r. And this one can be proven. It's just very clunky. But the best part of this one is if your ratio is between 1 and negative 1, I like to say absolute value less than 1. So like 1/2 or 1/3 or 1/5. Do you know what 1/5 plus 1/5 squared plus 1/5 cubed to infinity is equal to? 1 what? 1/4. Is that crazy or what? Now here's my favorite one. If you take a cookie and eat 1/3 of it, okay, then eat 1/3 of 1/3. Actually, this is going to be about 1/3 here. Eat 1/3 of 1/3. Eat 1/3 of 1/3 of 1/3. 1/3 of 1/3 of 1/3. What's 1/3 plus 1/3 squared plus 1/3 cubed all the way to 1 over 3 to the n? What's that going to be equal to? You will have eaten half of the cookie. Crazy. So patterns abound with this, but what it ends up being is the formula a over 1 minus r. Now where that comes from is that if r is less than 1, absolute value between 1 and negative 1, then what happens to this is this thing goes to 0. Because what's 1 over infinity? What's that? 0. So it's a plus 1 over 1 minus r. So that's where that formula comes from. And those are the three, actually four formulas for geometric. So if you want to list them out, it's a of n plus 1 over a of n. A of n is a times r to the n minus 1. And then sum of those is a times 1 minus r to the n over 1 minus r. Or sum to infinity, if your r is between 1 and negative 1, just a over 1 minus r. From those, you'll be able to solve all of the questions and problems that you're going to see on the assignment for today. So I'm just going to turn you loose on these. Start with the arithmetic. There's some arithmetic, and then I have some geometric. And those should add up to your 30 minutes for today. Go for it. Good luck.